I am starting your function. Function means function means, first of all, we have to decide on which type of function is not defined. Because every function is a relation. Every function is a relation. But all relations are not a function. Okay? Every function is a relation, but all relations are not a function. So, and what type of function are not possible? See, this one denoted by f, and this is first set and this is second set. Suppose we having some element a, b, c, d, 1, 2, 3 only. Now see, a having the image in 3, b is at 2, c is at 1, but d have no image. But such a function is not defined. Why? Because d is belonging to set A, but d have not an image in d have not image in set B. So such a relation is not possible. Function is not possible. Function is not possible. Keep in mind, this is really very important topic, because if D, although D is the element of A, but D doesn't have any type of image in B, so such type of function is not possible. Number 1. Number 2, A, B, C, D, and E also suppose, and 1, 2, 3, 4, 5. A having the image in 1 as well as A having the image in 2 also. B is at 3, D is this, and this is at this, and this is at this also. Because two element having the one image, it is possible, but one having two images. Now see, a element having two images, 1 and 2, and this type of function is not possible. Two elements can be imaged at one point, this is possible, but as for in mathematics, the function, such a function, if a element having the two images, is not a function, because A having two images, so this is not a function. This is not a function. And before going through the function, and first of all, you have to keep in mind both these things, because you have studied these things in class 11th also. A element whose this is known as the domain part. This is known as codomain part. If any element in the domain having no image in the codomain part, it means that this is not a function. Like the same manner, if element in a domain having the two images in the codomain, such a function is not possible also. Then how many types and what are the types of function in R4? Number 1 function. 1 function. See, suppose this is a function and first set and this is second set. A, B, C, D, and this is 1, 2, 3, 4, 5, and every element having the one image. See, 3, this one, like this way. Okay. All elements of A, B, C, D having the one images in B, and 5 doesn't having any type of image. But this is possible. This type of function is possible, and this is known as 1 function. And 1 function is also known as injective function. And here 5 is the element, and which is not having a pre-image. and this is not image of any element of A. So this is known as into function also. Into function. Now see, 2 onto function. What do you mean by onto function? Onto function is if all the element of set B are occupied by the all elements of set A, means at least all the elements will be the images of element A, then we can say that it is a onto function. But if any element is left, this is known as into function, and this is onto function. Onto function. Onto function means F A B C D 1 2 3. Suppose this is here, this one is here also, this one is also here, this one is here. Because now see, all the elements of A and all elements of B are occupied, and no element is left here also. And 2 elements can be have the same image, but one element doesn't have two images, but such a function is possible. Here no element is left, and this is known as onto function or surjective function. Surjective function. And one more function we have is third one, 1 and onto function. 1 and onto function. 1 means this one, onto means this one, means here, and 5 is left, but it's a function having one element having the one image, and no element is left in right hand portion, means in codomain part. See this one and this one also. This is function, this is A, B, C, D. 1, 2, 3, 4. Now see, one having one image, all having, now see, one element having one image. This is 1 function because one element having only one image, and no element is left here, and this is known as 1 onto. 1 onto is also known as, because this function is followed two types of relations. This is known as bijective function. Bijective function. And these three relations are really very important. One more relation we have. Now see, many one function. Many one function means if a set A and this is B, function F, A, B, C, D, 1, 2, 3 means many one, means like this way. Most of the elements, 1, 2, 3 elements are imaged at point 2, and this is at 3. This is known as many one. Means most of the elements are having the same image, and this is known as many one function. And one more function we have. One more function, fifth, constant function. Constant function means a function is like this way. F, this is A, this is B. A, B, C, D. 1, 2, 3, 4. All elements are acting at a point. This one, this is known as constant function. Its value is not depending upon the value of x. It is directly, like suppose f of x equal to 7. Suppose the value which is not depending upon the value of x, directly we can say that this is constant function. After that, one more important function we have. Next one is modulus function, and you have studied this function in class 11th also. This function f of x is denoted by mod of x. Mod of x means either its value is minus x or its value is plus x. If x is less than 0, here if x is greater than 0, then its graph will come and this is really very important, because this question will help you in integration also, for finding the area of bounded region by the integral part, and this will also help the intersection of the circle with the help of this modulus graph, modulus line. Now see how we can draw this line. This is x-axis, this is x dash, y and y dash, and we having the two lines, because we know that f of x is just denoted by y equal to negative x as well as y equal to positive x. We have two lines, so because x equal to 0, 0 is the turning point, so its graph will come like this way. This is f of x equal to minus x, and this graph is denoted by f of x equal to plus x, and this is known as the modulus graph. And one more example, this is example number 1, and suppose example number 1, f of x is equal to x plus 1 mod, x plus 1 mod. And how we can represent this modulus graph in graph representation of graph? Now see, x plus 1 minus, and this is x plus 1. Now see, mod of x plus 1 may be minus x plus 1 or plus x plus 1. If x plus 1 is less than 0, or if x plus 1 is greater than 0, it means x is less than minus 1, x is greater than minus 1. It means minus 1 is the turning point in the graph. X equal to minus 1, where x will come? X is minus 1 is here, x is minus 1 is here, minus 1 comma 0. So the graph will come like this way, because this is x-axis, this is y-axis. So y equal to minus x plus 1 will come, and this is y equal to x plus 1 plus x plus 1 will come. Like this way, this graph will comes like this way. And so many other graphs also, when you will start your exercise, and then you will study these things. Now see, the next one more important function is there, which is known as greatest integer function. Greatest integer function. Greatest integer function. And greatest integer function is denoted by mod of x like this way, and its value is known as less than or equal to. And everyone know about these things. What is integer? Integer means complete values, perfect values, like 2, 3, 4, 5, minus 2, minus 3, minus 4. All numbers which is starting from 0 onwards, and both the direction positive and negative, 0 plus minus 1, 2 plus minus infinity. Suppose we have 3.5. 3.5 means, what is the integer? Integer is 3. So 3 will come. 3.1, it will also come 3. 3.9, what is the integer? Integer is 3, because this is the decimal place. So less than or equal to will come, it means 3 will come. Suppose minus 3.9, and it's just less, what will come? Minus 4 will come. But how? Now see, number line system. 0 is there, this is 1, this is 2, this is 3, minus 1, minus 2, minus 3, and minus 4 will come. Now see, and we know that when we are going towards the negative direction, it means our value is decreasing. When we are moving towards the right hand side, it means our value is increasing. Suppose 3.5 is there. 3.5 means this is 4. 3.5 approximately here will come, but its value is coming 3, because from 3 to 3.999, and the value will come to 3. It means whatever we having the value here, and all value will act at 3, and this is not closed, this is open interval. Open means 4 will not include in that. Like same way, 2 to 2.9 here, all value will come here. like the same manner, all values will come like here, all values will come here, all values will come here, all values like this way. 3.1 minus 3.1 to 3.2, 3.3, all points will comes in the left side, and this is known as greatest integer function. And suppose we want to represent, and this is the number line system. Suppose we want to represent these things in 2D axis. 2D means x and y plane, x axis, and this is y1. And suppose 1, this is 2, this is 3, 4. Minus 1, minus 2, minus 3, minus 4, and so on. Means 1 onwards, all the numbers 1 onwards will comes down here. All number here will come down here. 3 2 means all number will come like this way. And here means 1 to 0 will come, and like the same manner this number will act here, and all these number will act here, and 0 will come here, minus 1. Like this way, in a 2D axis, we will represent this greatest integer function this way. And suppose we will study these things by the other competitive books. And there is two types of more greatest integer function. Number one is ceiling function. The ceiling function is denoted by this one, and floor function is denoted by this one. Ceiling function means less than, or floor function means more than. Suppose we have 3.4. Ceiling function means less than equal to, just less number will come. Less means 3.4 means 3 will come. And suppose 2.9 is here, means this is floor function. Floor function means above, the upper values will come. 2.9 means again 3 will come. Means these two types of function also have been given, but this function is not given in your NCERT books. If you will go through the any other books like competitive books, and you will see these type of functions have been given, and these questions only beneficial for you for the competitive questions, competitive areas, and these questions will not come in your CBSE examination. Okay, now I will start one more things, new. Although I have not discussed with you that time when I have studied the bijective function, because we know that the bijective function means like this way. Means, again I am repeating these things. Bijective function. Bijective means A, B, C, D. 1, 2, 3, 4 means 1, 1 on 2. 1, 1 and on 2. And this is also known as invertible function. If you will invert, means all the elements in place of A and B, if they will reverse to each, and all the numbers will reverse, and this function is also possible. But in other function, 1, 1 function, on 2 function will not satisfy, will not follow the rules of functions. Now see, this is also known as bijective function, is also known as invertible function. Invertible function. And one more function. But in this year, when the CBSE have reduced your syllabus, 30% syllabus, this one topic is also reduced, and this will not come in your CBSE examination 2021 from function chapter. But its use, you will see this composite function will valuable in continuity and differentiability, and you have to go through it, because although this topic is reduced from your books only for the function chapter, but here we have to go through it. Now see, suppose if 2 or more than 2 functions will join together, if 2 or more than 2 functions join together, then a function will becomes, and this is known as composite function. Because till here, and we were studying before this one topic, only one function have been given, only f. Now we are joining both these functions, f and g are the two functions joining to each other. A having the element A, B, C, D, and this is x, y, z, t. This is 1, 2, 3, 4. So A means the different elements is joined like this way. This one is like this way. And this function is known as composite function, because A is directly attached to Z and Z is directly attached to 4. Like the same manner, B is Y, Y to 2, C is to X, X to 1, D to T and T to 3. And this function is known as composite function. And how we can solve this function, because this function is very very useful. Suppose f o g, and this is denoted by f composition g. F o g means f composition g can be written f of g x. This one, this is the formula for that. Suppose f of x is given to us x square plus 1, and g of x is defined in such a manner that is 2x only. So suppose the question has been given. This is the question example also. So find f o f, f o g, g o g, g o f. And how we can solve these things? Now see solution of this concept. F o f, f o f x means as per this definition, as f of g x is written f of g x. So f of f x will write f of f x, and f of what is f x? F x is defined in such a manner x square plus 1, x square plus 1. Now f of x square plus 1 is to be defined, and assume, we will consider here this x square plus 1, and assuming this thing x square plus 1 is suppose capital X, so it will become f of capital X. F of x is defined x square plus 1, so f of capital X will come, f of capital X will come, capital X square plus 1 will come, 1 will come. So what is capital X? X square plus 1. We can put here the values. Capital X is to x square plus 1, whole square plus 1 will come. So you can open this with a plus b whole square. A square plus b square plus 2x square plus 1, x to the power 4 plus 2x square plus 2 will come. This is the value of f o f g, f o f. And 2, second part of it, g, f o g, f o g. How we can find f o g of x? What is the formula for that? Formula is this: f o g x equal to f of g x. Like the same way, we can write here f of gx. And first of all, we will write what is gx. Gx is defined 2x. You can put here 2x. 2x. So again, we can assume that capital X is equal to 2x. So f of capital X will come. Now check the how f of x is defined. X square plus 1. So it will come x square plus 1. Now what is capital X? That is 2x. 2x square plus 1, which is 4x square plus 1 will come. This is the second answer of this question. Second answer. Now see, like the same manner, come to the third part of it. What is GOG? G of x. GOG means G of GX. G of GX. What is GX? GX is 2x. 2x. Let us suppose 2x equal to capital X. We are assuming G of x is Gx is defined 2x again. This is really joke. 2x equal to 2x, 4x. Like this way, this is very very simple one exercise, and you can solve this question like this manner. Okay, and this is, although this is not in your NCERT syllabus in this year, but really very very important. Now I am solving some more questions. Only one question is solving. Now how we can solve the 1 function, into function, onto function, bijective function, surjective function. Now see, let us suppose question number 1 is given. I think in your books it is given that the question. I am solving the question number first. Now how we can find the 1 and onto function? The question number 1 have been given f of r to r, means r is non-zero real number and this is also non-zero real number, defined in such a manner f of x equal to 1 upon x. and we have to prove that this is 1 1 and on 2, 1 1 and on 2 for that solution. Now see, if f of x is defined in such a manner 1 upon x, so let x1 and x2 are belonging to the real number. Real number r naught means non-zero real number. So these functions will define in such a manner x1 equal to 1 upon x1 and f of x2 means 1 upon x2, and for 1 1 function, for 1 1 function f of x1 will equal to f of x2, 1 upon x1 equal to 1 upon x2. So cross multiplication x1 equal to x2 will come. If x1 equal to x2 will come, it means the given function must be a 1 1 function. This is 1 1 function. Which is 1 1 function. 1 1 function. But for this is 1 1 function. Now for onto function. Onto function, f of x is denoted by y. Y equal to 1 upon x. Therefore x equal to 1 upon y. We can put these values here only. And f of x is defined in such a manner. F of x means 1 upon y will come. Means 1 upon x equal to 1 upon y. It means y is coming. Y is also a values, real values. So given function is 1 1 and on 2. Because by changing the values 1 upon 1, 1 upon 2, 1 upon 3, all numbers are lying on the same place. Now see, suppose this one, because both are, this is the function, this is real number also, this is real number, r naught means 0 is not here. Suppose 1, 2, 3, 4, all numbers are here, 1, 2, 3, 4, all numbers are here, and 1 having the image in 1, and 2 having the image in 1 by 2, because 1 by 2 is also belonging to the real numbers. And 3 having the image here 1 upon 3, because this is the real number, not 0, and 1 upon 3 is also here. Means like the same manner, 1 upon 3 is also here, and 1 upon 3 having the image in 3, and we can change this one things, and like this way, and this function must be a 1 1 and onto function. And instead of that, the question having one twist also. One twist means if the real number is changed to the natural number. Real number is changed to the natural number means, now see, it is given to us, and this one having the real number, and this is the natural number, and this is the function, and is it the function is also 1 1 and onto. Now see, 1 2 3 4 all numbers are here, but here 1 2 3 4 only numbers, but these are the real number also, but here we don't have real number. Now see, like this way, suppose x1 and x2 are belonging to the real number, and the function is defining or not. F of x1 is same 1 upon x1, f of x2 is also same 1 upon x2 for the real cases. And for 1 1 function, 1 1 function means 1 to 1 function, 1 having the image 1 upon 3 should be here, 1 upon 3 should be here, but we don't have any 1 upon 3 here. So 1 upon x1 equal to 1 upon x2, x1 equal to x2 will come. But in case of onto function, we don't have any reciprocal number of these elements, so onto function is not possible. Onto function is not possible. So solving this question, and first of all go through these functions, definition of the function, then you can solve, otherwise you get problems. Okay.